So we've looked at how method overriding works, but let me give you a better reason to use method overriding. Say you want to create a collection, like an array, full of shapes of various types. And let's say you do this in one part of the code. You load from some database and you build up the whole mess of shapes. And you just throw them together in this array of shapes. So let's try to simulate that. And instead of a database, we'll just manually add in a few. First, create a rectangle. Circle. Square. And that's good enough for now, actually. 3 will be enough to demonstrate. And, so we forgot this closing parentheses. And let's add another function to our hierarchy, just to display it. This will return nothing, but internally, it will print the type and the area and the bounding coordinates. So first we want to return a type as a string. This is the base class, it's just shape. And here we return rectangle. Here we return square. Here we return circle. Okay. And so when we display, we want to call that type function to print the type. And then we want to print the area. And actually for now, that's probably okay. Let's just do that for now. So if we declare that, and then we've added a bunch of shapes to our array, now much later in the code, say in another part of the code that doesn't really know how this stuff was built, we want to just display what's inside our shape array. Keep in mind, this array is of type shape, but really under the hood is a mixed bag of all these specific kinds of shapes. But the code doesn't know that. The code only knows that it's an array of shapes. How's it going to do? Like, is it going to be able to print out all these things that are at the subclass level? The answer is yes, because that's the point of overriding. Function overriding gives us the power to have, for example, a very generic container of objects, but then still have behavior at the very specific subclass level show up. So for instance, if you want to do for S in shapes, and then for each one, just display what's going on. Sure enough, rectangle, circle, square, those types are being displayed, even though that functionality doesn't exist at the top level, right? The top is returning just shape. It's the subclasses that are providing the correct type. And same thing goes for the area. The area is being calculated at the subclass level, as you can see by the values, not at the shape level. This, even though at this point in time, shapes, in this part of the code, shapes is only known to the code as an array of type shape, right? But it basically magically drills down to the lower level to implement or to run the functionality that's declared at that level, all because of this keyword override. Okay, so hopefully you can see the power of this. It allows us to have very generic code, but then the behavior be very specific. Okay, so that's the power of overriding functions, specifically when we use them in collections.